Okay, this is the video ME 3360 for homework 3, problem 2. So problem 2 asks you guys think about this electrodynamic the shaker here, and this shaker has the connected with this test platform. So, but you think about it, it may be assumed to have the negligible the mass. So you can use just mass m, not the separate mass, something like m1 and m2. And also we have uh, the test consists of the shaking the connector at the frequency, at this frequency 2 pi times 100 radian per second. And we have all the parameter here, right? And this question asks you guys to determine the peak amplitude of the sinusoid voltage, the Vs required, determine the Vs required to generate the acceleration of the 5G. 5G means the 49 meter per second scale, right? So the final equation, you should get the Vs, to get this acceleration for x, right? So here we have the uh, three input. The first input to IF to make a field coil, but this IF doesn't give anything to the system except to generate the magnetic flux, right? Yeah, kind of this magnetic flux. So you can think about it. This make this structure like some permanent magnet to generate the magnetic flux. Mm, yeah, right. So you don't need to consider about this IF. Uh, what you need to consider about it is this electric circuit and this mechanical part. This electrical circuit has the voltage source, voltage input, but we have the inductor and resistor here. So there is some inductor and resistor here, right? We have the coil and resistor here. So that means yeah, that means you have the voltage source Vs, right? You have the coil and resistor, and also have the back EMF. This is plus and minus, something like that. So this is your coil and resistor and back EMF, like that. The second thing, the mechanical part. So you have the mass here, and you have two resistor force. One is the spring force. Another thing is the damping force. And you have the input force, the V and I, right? From the system. So from that, you can get the equation based on the Kirchhoff voltage law. So Vs equal to L di over dt plus your resistor Ri plus Eb, right? So this Eb is equal to what? The dLu, right? U is the dt over dx over dt. So your Vs is equal to L I dot plus Ri plus dl x dot, right? So your second equation. So you can get mx double dot plus bx dot plus kx minus bli equal to 0. So you can start from this equation. So if you try to Laplace transform for these two equations, so you can get the SL because it has the derivative term, so you can put the S here, the SL plus R, the current IS plus B L S X S, right? So this is equal to Vs. And the second equation, the ms squared plus es plus k xs minus b a I s equal to 0. So to express this to the matrix form, so you can get this n bls minus bl ms squared plus bs plus k, right? And this should be is and xs equal to vs 0. So you can try Cramer's law. Cramer's rule. So this xs equal to what? Determinant as a plus r minus ba, and you can plug this vs to 0 to second position because you want to get the xs, the second position. So you can plug the vs and 0 here over determinant this equation sa plus r vs, not vs, sorry, the bls minus ba ams squared plus bs plus k, right? So you got the xs equal to minus bl over, right? Because this should be 0, and yeah, yeah, minus bl yeah, I think it should be plus. Yeah, because this should be 0. This vs times the minus bl should be equal to plus bl, the vs. And also determinant here, the sa plus r times the ms squared plus bs plus k plus ba square s, right? And vs. So from here, so finally what we want to get is the x double dot, right? The acceleration. This acceleration is the s squared and x, right? So that means this is the bas squared over ln s cubed plus ba plus rn s squared plus b r plus k inductance a plus ba squared s plus KR and Vs. Right? Here, when you plug the S into the frequency domain, because we know about the frequency W, we want to get the magnitude about the voltage at the certain frequency, right? So the transfer function, acceleration over the input, the voltage source is equals the transfer function equals minus BL omega square and KR minus BL plus RM omega square plus J times BR plus KL plus BL square omega minus LM omega cubed. So this is our transfer function in time in the frequency domain. So when you plug the omega equal to 2 pi times 100 radian per second, so you get this magnitude as a 0.1273. So finally, so we get the x j omega and t j omega equal to v, the magnitude of the voltage vj omega, right? So we know about this one. What was that? That is 49, right? And t was the magnitude of our transfer function was the 0.1273. So that's similar to 385 voltage. So this is our final answer for problem 2. Thanks.